All right, in section 5.1, I'm going to start this video with number 11. We have 3x squared over y squared times 3y over 6x. Now, there's a couple of ways we could approach this. One is just to start canceling out stuff before we put stuff together. And that's what I think I'm going to do. We could go ahead and multiply first, but if we were multiplying fractions, a lot of times we would try to reduce before we try to put stuff together. So let's try that here. For instance, I see that 3 goes into 3 once and 3 goes into 6 twice. I also see that I have an x down here. This x will go, if I say I divide x out of x, it goes in one time. But if I divide x squared, I divide x out of x squared, there would be an x left over. So I can kind of reduce that way. I see there's some y's. I could cross this y out and say, okay, there's one y there. I take one y out of there. There's a y left. Let's see what we got now, okay? That's probably the quickest way to do this. I could just rearrange all the terms and write them down and then cancel out. But it's kind of nice to get rid of some stuff if we can. On the top, I have 3x times 1 is 3x. And on the bottom, I have y times 2 is 2y. And looky there, we're done. One of the reasons I could do this is because I was multiplying things. When we're multiplying fractions, we can do that reducing and then just, kind of put everything together at the end. 13, let's see if we can do something similar. 13, they've already put everything together for us. Okay, so it's r s squared t cubed, or r cubed s squared t. All right, we got to remember our exponent rules. And again, if we've got fractions, that's like division, right? And so the rules for exponents, if we have division or fractions, is that we subtract the exponents. Now I'm going to come in here and I'm going to do something. I am going to fill in, that r doesn't have an exponent. It really does. It's the invisible 1, so I'm going to write it in. And then on the bottom, I see that t, it's just a t to the first power. So I'm going to write it in, and that's going to help me with my subtraction here in a minute. All right, let's do one variable at a time. Let's start with the r's. I have an r cubed on bottom and an r1 on top. So how we do this is we subtract the exponents and we write the answer on the side that had more to start with. Okay, so I have r cubed on the bottom and r1 on top. 3 minus 1, if I subtract the exponents, is 2. So it's going to be r squared, and I'm going to write it on the bottom because there were more on the bottom. I could have done this. I could say there's 1 r on top and there's 3 r's on bottom, and that one cancels out with that one, and I'm left with 2 on the bottom. I could write it out the long way that way, but we're trying not to do that because it takes a lot more time. Let's move on to the s's. I have an s squared on top and an s squared on bottom, and they would just cancel each other out. If I'm thinking about exponent rules, it would be s to the 2 minus 2 would be s to the 0, and anything to the 0 power is 1. So if you actually subtracted the exponents, you'd still get them to cancel out and get a 1. All right, now let's move on to the t's. Here they are. I'll circle them in green. If I subtract the exponents, there's a 3 and a 1, so 3 minus 1 is 2. So I've got a t squared. Well, it's going to go on top because there were more on top to start with. And again, the reason that works is because if you actually wrote it out the long way, if you had 3 t's on top and 1 on bottom, you would end up with the 2 t's on top. So our answer is just t squared over r squared. All right, for problem number 15, we have, we're multiplying again, and they're going to make it a little harder now. We've got u squared over v times 3v over u squared squared. Now, before I can really start messing around with this, I need to apply that exponent, this 2 right here. I'll circle it in yellow. I need to square everything inside that parentheses. If you remember, we're still simplifying. So we're thinking PEMDAS, and PEMDAS says you do parentheses first, and then you do exponents next. Sorry. So I'm going to say, okay, I'm going to leave the first term alone, but I'm going to square everything in the fraction. And that square goes with both the numerator and the denominator of that fraction. So when I square 3v, 3 squared is 9, and then you square the v and you get v squared. On the bottom, I've got u squared squared. Well, that would be a power to a power. If you remember, if you have like u squared squared, you multiply the two exponents. 2 times 2 is 4. All right. Now, one thing you can do, if I kind of went a little too fast on one of those other problems, let me take a little more time with this one. Maybe we rearrange stuff. If I'm multiplying, I could just smoosh everything together, right? So I could put the 9 out front, and I could put the v squared here. And on the bottom, when we multiply fractions, we just smush it together too. And we always kind of put our letters, our variables, in alphabetical order, and that way it makes them easier to mess with. Because now if I've done that, I can go, okay, let's take one thing at a time. Let's take the numbers. There's a 9 on top. There's nothing on the bottom. Nothing's going to cancel out. I'll still have a 9 on top. Now let's move to the u terms. Here they are. I've got an exponent of 4 on the bottom and an exponent of 2 on the top. 4 minus 2 is 2, and where am I going to write that? I'm going to write it on the bottom because there were more on the bottom to start with. Again, if you write that out the long way, you would see that there would be 2 u's left on the bottom. All right, v squared over v. Well, there's a 1 on that v on the bottom, so I can subtract my exponents. 2 minus 1 is 1, and where were there more of them? On the top, so the v to the 1, which is just really a v, goes on the top. And I would write my answer as 9v over u squared. 17. And on number 17, we have 4r squared s squared squared over 4r squared s squared. All right. PEMDAS says we work in the parentheses first, but there's nothing to simplify in any of the parentheses that we have here. If you think about what comes next, after parentheses comes exponents. We need to do the exponents. Well, we have a parentheses with an exponent on the outside here of 2. Now this, I'm just looking at the top first. I got to square everything in that parentheses. So you got to be careful here. What's 4 squared? It is not 8. It is 16. R squared squared, you would multiply the exponents because that's a power raised to a power. So you would get r to the 2 times 2 is 4. And then on your s, you also have a 2 raised to the second power. 2 times 2 is 4. So you'd have s to the 4 on top. Now, let's look at the bottom. We can't really do anything till we get each term squared on the numerator and the denominator. So looking at the denominator now, we've got to square everything in that parentheses because there's a 2 on the outside. So this square has to go with everything in the parentheses. 4 squared again is 16. R squared squared, 2 times 2 is 4, so that'd be r to the 4th when we multiply our exponents when we have a power to a power. And if we have s and we just square it, it's just s squared. I could have also put a 1 there and said 1 times 2 is 2, okay? Now let's look what's going to happen. This 16 is going to cancel out that 16. This r to the 4th is going to cancel out that r to the 4th. And then I've got s to the 4th over s squared. Well, the exponent rule, this is really division, right? Because a fraction bar is another way of writing division. It says we just subtract our exponents. So it's s to the 4 minus 2. And it's going to go on top, right? Because there's more on top. And so my answer ends up just being s squared.